Gabe can say that, but I can't say that he's the calculus doctor who's constantly heals us in his math hospital.
You already did. Okay, Lahopital, you learned a little bit about last year. What did he do for us?
He made it. He made it so we could do limits at 0 when the thing was 0 over 0 or infinity over infinity.
He made it so we could do limits when we have 0 over 0 or infinity over infinity. And if we have either of those two indeterminate forms, is what we call them, then we could take the derivative of the numerator over the derivative of the denominator, not the quotient rule, but just the separate derivatives, and then we could evaluate our limit from there.
Why does it say or Bernoulli's?
Sounds like a dude.
Oh, because he
Is he a thief?
likes
I would
it
have
too.
some Bernoulli pasta.
I didn't hear that over Gabe's pasta joke.
Okay, now this is kind of like our warm-up. Okay, what do we remember from last year? Okay, because there are actually more indeterminate forms than 0 over 0 and infinity over infinity.
Maybe.
Now, these are the ones that we can use L'Hopital's rule for. The other ones we're going to have to finagle algebraically until we get them to that form. But, let's warm up. You ready?
Yeah. As ready as I'll ever be.
All right, write it down. Anytime you are going to evaluate a limit, the first thing you should try to do is
Plug in the number.
plug in the number. We call that direct substitution.
That's 0 over 0.
Okay, Lillian, what do we get when we plug in?
0 over 0.
All right, and 0 over 0 is indeterminate. I do want you to write which indeterminate form you're working with, kind of as a reminder to yourself as, I need to do something with this. Okay? So, we can use L'Hopital's rule. The derivative of the numerator is 3e to the 3x over the derivative of the denominator is 1. So when we plug in 0, we get?
That's so nice. Why do I feel like it's going to get ugly?
I have a bad feeling.
Physics.
Oh boy.
Some of us need to recall what certain graphs look like. Okay. The natural log, please make it with your arms.
Is it like this?
It's like this one.
Like this.
It's like you walk in the
Okay? And as we go to infinity, it continues to
reach 0.
continues.
I don't know. Isn't there like some kind of asymptote at some point?
Well, at 0, but towards infinity.
It's just like yoink.
Oh, okay. It's just like a regular logarithm.
Yes. Well, you're gonna say
Yoink is the opposite of
Yeah, that would be E.
okay, and a square root. I mean, kind of has, I wouldn't say same, but it has a similar effect towards infinity, right? So we have infinity over infinity. It is indeterminate. If we have an indeterminate form, then we can use L'Hopital's rule. So the derivative of the numerator, 1 over x, the derivative of the denominator.
1 over radical x.
How do you feel about that?
I like this one. Because then you can just put radical x over x.
Group me is.
So wouldn't it be 1 over radical x if we simplify it? Right? We have x to the negative first divided by x to the negative half. So when we subtract them, we have x to
Oh
the...
boy.
towards infinity. What happens to radical x as we go towards infinity?
It becomes infinity.
Okay, so if we have 1 over approaching infinity,
It equals 0.
goes to 0.
Limits are not as bad as I used to think. They're friends.
Not quite yet. Not quite.
Wait, why are you giving?
Okay, so towards negative infinity, x squared is going to rise. Towards negative infinity, e to the negative x is also going to rise. E to the negative x is exponential decay, right? Okay. So we know we can use L'Hopital's rule.
The man.
We should make hotel shirts.
That's what I slapped on saying. Next year we should design the shirt for next year. Has that ball.
I'm sorry.
You
have
can
to.
still design shirts for this year, and
Yeah,
we can still order
it's
them.
only October.
Like I have to pay
Cool.
more money.
You can design
Okay,
shirts
so I have an issue. What's your issue?
Life.
No.
But then you're not getting.
Here
I mean,
we have negative infinity over
Negative.
some kind of infinity,
It's
right?
negative. So.
Why can't we just cancel it out and make one? Why is that not a thing?
Because infinity is a
Bigger than
quantity.
the other infinity.
I'm not
Some infinities
So we
are
have to
bigger
do
than
this
others.
again, and I'm going to get to your point here. I'm going to get to your point. Okay? So we have here. Okay? Y is infinity over infinity, not 1. Okay? We have different,
Infinite.
right.
There are infinite numbers between 1 and 2, but there are also infinite numbers between 0 and infinity.
That's the way to look at it. So it's not like a quantity. Well, what about 0 divided by 0? Why isn't that 1? Well, when we divide by 0, okay, when we divide by 0, we're told that that's not okay, right?
Why is
Because
that?
dividing by 0 can be any number.
Because how do you take 5 groups and divide them into 0 groups? Like, you can't do that. Okay. Now,
Bye-bye.
we have more indeterminate forms. Write these down, because if you don't know these, you will not know how to do L'Hopital's rule. And I'm going to tell you right now, one of the questions on your quiz Thursday, what are the indeterminate forms?
Oh boy.
0 over 0, infinity over infinity,
Well, 0 times
and
infinity. 0 times infinity feels like that.
Just 0 to the 0. Is it 0? Is it 1? We don't know. It's
Yes.
indeterminate. 1 to the infinity. Is it 1? Is it infinity? We don't know. It's indeterminate.
Wouldn't it be
What? That's
one?
what.
Infinity minus infinity.
Okay, I can understand where that one's.
Thank you.
Okay.
0 times infinity. Is it infinity? Is it 0? We
Okay,
don't know.
that one.
Hurts my brain.
Infinity to the 0.
That's
Is it
one.
1?
That's
Is it
one.
infinity?
I don't like
It could be 3.
That's
We
how
were told
it's negative
any
infinity.
value
Duh.
to the 0.
But infinity isn't a value.
But infinity could be any value.
0. No.
What if we find out the
Okay,
last
okay, everybody knows whenever you're trying to find the limit to infinity, you just plug in like a 999.99.
when you
No, that's not.
Wikipedia article
Exactly.
list of images? This list
It's
is
just a real
What?
thing.
You
I'm
can
like,
help by
Zero times
expanding it.
You know what I could see
That is
happening?
not indeterminate.
What is it then? Is it 0?
zero.
We can still use the rule, but we must
What's
first
Shouldn't it be the
convert
same
them to.
concept for
Is
one
0 minus 0 indeterminate?
I feel like
Nope, that was
Yes,
0.
yes.
I feel like you
Okay.
can make an
What
argument
if
for
zero
the infinity to 0, but one's the infinity has to.
Well, that would just be 2 infinity. Duh.
Oh, that's right. I mean,
I
yeah, I guess.
I need to write
Top
these down
10
before I-
smartest.
It's really hard to discuss this when you're all like yelling randomly.
I like that.
Okay.
word.
But why
Okay.
is 1 to the infinity not 1?
Well, we have this rule, right? 1 to any power would be 1.
Yes.
However, if you're talking about a number to the infinity, power, it's supposed to like grow and grow and grow and grow and grow, right?
That's not.
I mean, the power
Well, like
is
when you think
gross,
about it,
but
it's
it's
just
still,
one times
it's
one
still
times one.
one.
It would just be
The
one
number
times
of
itself
terms
forever.
is infinitely growing, is it not? Like when you break that down, it's when you're giving an exponent, it's 1 times 1 times 1, and that number of terms is infinitely growing. If it's always infinitely growing, you're always going. It would be.
Big
Right,
nerd.
to the American Math Society game, you tell them.
You tell him the truth.
Is one a prime number?
No, 1 is not a prime number because 1 is
We are gonna go through a couple examples, and then we can come back and argue about this in a little bit.
prime numbers
Okay.
must be greater than.
It's
Really?
That's
Big. Oh, what is this? It kind of looks like it
Okay.
says line.
Nice.
no, limits for the worst part of this. No,
Whoa.
difficult money. Yeah, difficult money.
They're half and half money.
I hate.
Oh,
We're switching over now. Are you done with
You
this?
have to ask your husband if his students ask him questions like
E to the negative x towards infinity,
is
0.
x squared. Okay, you see how 0 times infinity is indeterminate?
Yeah.
Excuse me. The problem with infinity is it's not an actual number, it's a concept. That's why we're having these indeterminate issues.
Make it a number.
Okay. So now I cannot use L'Hopital's rule unless we have a fraction. Is there a way for me to make this a fraction?
Oh yeah.
X squared over e to the x, which would now give me infinity over infinity, and now we can apply L'Hopital's rule because we have a fraction. Yep. Well, we gotta go again, don't we?
We need to go deeper,
Okay.
Neo.
We get 2 to the x over e to the x, or 2x, excuse me, over e to the x, still infinity over infinity, so we're going to have to use L'Hopital's rule one more time.
You know, I think L'Hopital's rule and me are going to be real good friends after this.
Yep.
I think we're already real good friends, so you should check yourself before you wreck yourself.
Okay.
Wait,
So wait.
Check yourself before
So
you shrek
all of
yourself.
the
Make sure you have enough.
all the other indeterminate factors are always going to
Someone
be
should make a
form of
PSA
0
where
over 0 or
Shrek tells
infinity
us the importance
Yes.
of wearing
Okay,
letters.
Lillian just asked a very good question that I wish you would have listened to. It was more like an observation. All of the indeterminate forms we can rearrange to eventually get to 0 over 0 or infinity over infinity. Yes, that is the goal. Okay? Now, that might look differently with each problem, but we're going to be able to finagle it that way using some algebra.
Alright,
I
so
love
if it's like
that.
negative infinity over negative infinity.
That's fine. Or negative infinity over a positive infinity, that's fine too. Okay, those are all plus or minus infinity over infinity. Okay. Okay, write this down.
That's not so hard.
No, I'm sure.
Calculators?
Yeah.
Is there even a way to get a calculator to represent?
Write a program.
1 times e to the 99.
You just hit the A button and then hold your calculator sideways.
Yeah, see, infinity. Avengers.
That's a
use
lot
it
of
as well.
1 and 0, isn't it?
Avengers.
'Kay.
Sideways equal.
This is natural log. As we approach 1, we get
0.
minus what?
Wait,
It
that's
would
one
be
over
1
zero.
over 0.
Yeah.
So it would be positive infinity. Wouldn't it?
Okay. Boom.
Okay.
I like this. Infinity minus infinity. My favorite.
How did you get to
Okay.
Infinity O's.
Okay, so if we have infinity over infinity, infinity minus infinity. We know it's indeterminate. We have to use L'Hopital. But we need one fraction in order to be able to use L'Hopitals.
I'm still stuck on that. How'd you get from 1 over 0
That's
minus
what
1
I'm
over 0
Oh, are
to
we gonna
infinity
just like
minus
multiply them? And divide
Well,
them?
if we have 1 over approaching 0, your denominator is getting so small that 1 over those really small numbers approaching 0 turns to infinity.
Big dude.
Like 1 over a small number creates a big number. So
You can divide.
as we approach 0 from the positive side, we have 1 over 1/2, 1 over 1/3, 1 over 1/4, 1 over 1/5, 1 over 1/6. Those are gonna get bigger and bigger and bigger and bigger.
Yeah,
Okay.
sounds good.
All right, so if we're gonna use the L'Hopital's rule, what are we gonna have to do?
Make it a
Cross
single
multiply.
fraction.
Okay, we need common denominators, right?
So you're gonna multiply by the greatest common factor or lowest common, and not the 1
Yes.
or 2.
So that.
Wait, wouldn't it still be natural log? No, because cross multiplication, that's right.
Well, it's not cross multiplication. We got a very stern talking to you about that. On
It is
social-
cross multiplication.
Oh, it's common denominators. So now we have,
It's the same thing.
now we have 0 over 0. Do you agree?
Let's see.
Yes.
Yeah.
Okay. So let's apply L'Hopital's rule. The derivative of our numerator.
Well, that's 1 minus 1 over x.
Okay. The derivative of our denominator, well, we have a product.
Oh boy.
My favorite breakfast. Well, then you have 1 minus 1 over x times
Isn't that just 0 over 0?
natural log of x.
One minus 8 over 0.
Oh, that's
0 over 0.
big boing pounds right here.
Over.
I have no clue what is happening.
0. Oh man.
What are you manning?
I just
Yeah.
got to the 0 over 0 part.
Oh, we have 0 over 0 again.
Wait,
Yeah. Right?
Yeah, because 1 minus 1.
1 minus 1 would be 0. 1 minus 1 plus 0. Okay, that's okay. We can just do it again. It's not a problem.
wait, but can't you multiply the? No, that's not how it works.
Yes.
Okay, so it's the limits coming to the right, does that like have any effect on it, or is that like earlier in the problem?
That was more, like when we had the 1 over 0, that's when we had to decide, like,
Okay.
which infinity it was going to approach.
So if it was approaching from the negative
Oh,
side,
I
you're
just
negative.
read the
Yes.
Okay.
Yes.
dx plus c.
Okay, so now we have the derivative of our numerator is 1 over x squared. The derivative of our denominator is 1 over x squared plus 1 over x. Yay.
1/2. Oh. What? Oh.
Radical.
Radical, bro.
What would this be?
1/2.
Oh, we never said the pledge.
Hi.
What are we pledging?
What?
Ooh.
Yeah, did we do the pledge? I don't think so.
Yeah.
I know, but do they know
Here,
that?
use this one.
Okay,
See if you
bye.
have a vibrating one.
Jackson
Or
Hazelhurst.
and club someone with it.
Sir
When you
Johnson,
use
we need you.
Get it?
I mean, I guess I didn't say that. Are you okay with going now?
The example someone
Yeah.
used was,
Thanks, Jackson.
Or do you want me to tell them you're gonna come at the end?
I hate dopamine.
Again?
Okay, during meetings, you probably better go now.
We have a
You'll be
story,
fine.
but it's actually
Okay, 1/2?
a story because it's
I think
just
that's
all around.
Yeah?
Doki Doki is the equivalent of a scientific junior bachelor.
Yes.
Like it's
Do you
1/2.
do you need Darby as well?
Okay. Uh-huh.
This is a national merit thing, probably.
I don't think they know this.
Don't you know, Mr.
I don't know,
Sonic?
maybe they must have.
At the same time.
We're all special too.
Okay, write it down.
Hey, you said it.
Okay,
That was
you
like perfect
absolutely
timing.
have.
It's okay.
Oh boy, what is this one gonna be?
Wait, what was the answer to the last one?
One half.
One half. Write it down, and then discuss what makes it indeterminate.
Well, it's 1 to the infinity.
Shh, I said discuss.
Disgusting.
This is absolutely
Oh, boy.
disgusting.
This just makes me sad.
Oh, it's to the X.
It's big, dude. Now, how do we get it out of here?
Okay, well, first of all, you get 1 plus 0.
Okay, when you use direct substitution, what is
You
happening?
get 1.
1 to the infinity of power.
1
Favorite one.
to the infinity.
Let's hope the actual answer isn't 1, so there's a reason to do this.
I can tell you right now by looking at it that it's 2e.
Oh.
Without
2E.
looking at my stuff,
I don't like
I know that it's 2e. Or I mean, excuse me, e squared. I know that this is e squared without looking at it.
Crunchy.
Are you ready?
Yeah.
I'll show you later.
I hope that that's the kind of thing that you do like power rule and not have to go through all
Okay, so here's the thing. We
The base.
have this with an exponent and we want it to be a fraction.
Yeah.
What's the only way to take something that has an exponent and not make it have an exponent anymore?
Logarithms.
Logarithms,
Oh.
yes.
Okay, I have a
Okay, on
question.
who actually knows how to find the root of the
Miss Coleman, I have a question.
normal?
Yes.
Will you ever have infinity to the infinity?
No,
It's possible.
I got my
Is
ass.
that an indeterminate?
No, we can say that that's infinity. Yeah, we can. Okay, so e to the natural log. What happens to those two?
They equals 1.
They undo each other, right? So if we write e to the natural log of the limit,
Okay. Oh,
What?
whoa, we're living in 2050.
We've got.
I have not mathematically changed anything. Do you agree?
Yes, because it's just one.
What, Victoria?
I just said you just wrote more letters.
I just wrote more letters.
This is
And then what we can do is I can rearrange where the limit and the natural log are. Okay, because that's a property that you talked about last year, probably in September. Like you can take the limit of the natural log, or you can take the limit of what's inside and then apply it to the natural log. Do you understand what I'm saying? Okay, so that's what we're gonna do.
I thought it was just that multiplication. was,
Now, if we have a logarithm, what can we do with that x? We can throw it out in front, right?
yeah.
So we have x times the natural log of 1 plus 2 over x. Okay, we are almost there. At this point, we're at infinity times 0. We're at infinity times 0. I didn't think too hard about that one. Okay,
Oh, we have to fix it again?
we have to fix it because what do we want ultimately?
A fraction.
We want a fraction. It's not a fraction yet. So
Yes. Me too.
I'm stuck with the natural log of blah, 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 blah. But I can take x and write it as, dividing by x to the negative first. Do you see what I did? I just changed the exponent when I put it in the denominator. And now we have a fraction.
We got in a
Just
big
feels
trouble.
like it's too
Yeah?
Yeah, we got suspended, both of us. But they're letting us stay for the end of the class period.
Oh, that's kind of it.
What
Okay.
actually?
I told you.
It feels like it's getting out
Were
of
you
hand.
here for the beginning of the problem?
No.
Okay. So we have 1 to the infinity, which I know is your favorite.
I like the frowny things.
And so what we did is we put e to the natural log of the limit, because e to the natural log undoes each other.
Yeah.
And then I rearrange the natural log of the limit to be the limit of the natural log.
Oh,
And I took the x to be down in front,
Because you can do that.
because we can do that. But to use L'Hopital's rule, we want a fraction, so I took x and moved it to the denominator as x to the negative first. So now what we can do is use L'Hopital's rule, which is always an enjoyable experience. 1 over what's inside times the derivative of what's inside.
I feel like the worst one is gonna be 1 to the infinity.
That's 0 over 0, right? The last one, right?
Oh yeah, this is 0 over 0. Yep, which is a good thing to check, thank you. How do you feel about the derivatives? What don't you get? You said I don't really like it. Oh, you don't like it. I said I don't get it, but that's fine. Like, no, that's not fine. Okay, you don't like it. Nah, no. But
Does
what's nice
anyone
about
really
it?
like it?
Oh.
Right.
Oh.
Oh.
I
I
see the problem now.
Boys, y'all forgot to put stuff in it.
Okay, so what's the limit as x approaches infinity of 2 over 1 plus 2 over x?
0?
2.
Because this would go to 0, right? That guy would go to 0. So we have 2 over 1 plus 0,
So it's e squared.
which is what I said it would be.
E-A
It's
squared.
actually squares. It's not the same thing.
So wait, is it e raised to that the limit?
So this is e to the limit of this. So since we got the limit to be 2, it's still with this e. So it's e squared. Because we have that natural log to begin with. But when we used L'Hopital's rule and we took derivatives, the natural log went away.
That's crazy.
Yeah.
You still like it?
I don't like it.
Shouldn't 0 divided
Okay,
by
now.
just be all real numbers,
I feel like I'm gonna struggle with it.
Yay.
I might get like a between a third and a half.
Like every quarter.
Like sometimes we have
Okay, so I want to tell you, I don't know if this is ever something that you've seen. It may have been if you asked about it in an Algebra 2 or pre-calculus class. But there are 2 different definitions of E. This is one of them. Do you notice how similar that looks to what I just gave you? The only thing that was different was this 2 right here.
Oh boy.
Okay, so sometimes you're going to be able to recognize that. I'm going to tell you right now, I want to see you do the work, okay? Because I want you to understand how to do a problem set up like this. But you're going to be able to know what the answer should be, so your limits should work out.
Is there
Okay.
a proof that shows that equals the other definition?
What?
What's the other definition
It's
of
what do
E?
you call
Like
it?
1 over 1 plus
Yeah.
1 over 1 plus 1 over 2 plus 1 over... It's like 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial. That's the other definition of E.
That's pretty neat. That there's these things.
How does
Euler,
it
he's a
greater
great
than
guy. All right, we better do one more
Oh goodness.
or 2 more.
No, I like when you're
That's how it starts.
I don't know if my brain can handle this.
That's
Zero
This
to
one doesn't
zero.
look that bad.
when you make up a histochrome. Y'all ever just burn histochrome all over
Is this indeterminate?
0 to the 0.
Yeah.
What does this max look like?
Okay, I'm thinking about
It's just infinitely increasing.
Yai.
Can you draw x to the x?
It's just an infinite
I
increasing.
feel
Like
like it's like
one
that
over
half
one.
the problem, but more exaggerated.
It's well, it's got like a negative written down.
Hey,
It's just an increasing.
what's it turning on? I don't know if I remember what x to the x looks like.
I'll look it
It's
up on
kind of
Google
weird.
Yes.
It looks like my
Like that.
face.
Why is it only a domain of greater than 0?
Because
Because 0
negative
to
1
0
is
is not a
negative.
thing.
You can't take it.
Too many questions. I feel like I plugged
To the left, like,
If you want to take negative right,
you can't have even roots with negatives underneath, so negative 2 to the negative 2 isn't possible. Negative 3 to the negative 3 is okay. Oh, wait, excuse me. Like to the negative 1/2. Like negative 1/2 to the negative 1/2, not okay.
Oh, so it's just like points, and that's why it doesn't. So
Right.
that.
So what it, you just like have like, oh, that's odd.
No, yeah, because if you go to the table, you still get points at
Yeah, it's just like it'd
Ooh.
be like.
numbers.
That's wild.
Okay.
or
Alright,
But
so-
maybe like a-
Since we have this exponent case, what method do I want you to do to get this?
Good question.
To
Let's
fit-
start with L.
Natural log.
0.
So e to the natural log of the limit of x to the x. Okay? When you have an exponent indeterminate form, you have to do the e to the natural log so that you can finagle with properties of logarithms.
What is the technical term for what's underneath the limit?
Base? Or
Like what we're approaching,
As in, like,
the number that we're approaching. I mean, I guess I
care if
don't
write
know
the
our
number
limit.
we're approaching the
Well,
entire
no.
degree down, do you remember? I gotta do try to look at it too.
Well, that's fine then again. Just don't stop writing limit.
Well, no, I'm just not gonna write x equals 0 plus.
Okay, so the whole point is so that we can write it as a natural log. And what would we do with that exponent? Drop it down in front. Okay, we've now gotten it to the point where we have e to the 0 times infinity.
Wait. The natural log of 0 is infinity. Oh, that's right.
The natural log of 0 is undefined, but it's approaching the asymptote, so it's going, well, I guess it'd go towards negative infinity. Which you can obviously see as I wrote it down.
Wait, I just had, I don't see what that is. Like,
Natural log graph looks like
no,
this.
Can you like rewrite what you wrote in that corner?
I mean, I
I'm
can
pretty
try
sure
it.
negative
It's not
0
around.
exists in some field.
You could go down a little bit.
Oh yeah.
So, let's go ahead and rewrite this as a fraction. Okay? We can take some advice from our problem before last, right? Or we can take that x out in front and rewrite it as a denominator instead. Okay? That's going to be what has to happen. No matter which of these problems you're doing, that exponent that you bring out in front is going to have to somehow become your denominator. You're going to have to rewrite it algebraically to do so. Okay? So now we have infinity over infinity. So we can use the Hotel's rule. So now we have the limit as x approaches 0 from the right of 1 over x divided by negative 1 over x squared, which would reduce to what?
And I thought that would be infinity over negative infinity over 0. It's 1 over. It's 1 over 0. That's right.
Negative x? And what is the limit as x approaches 0 from the right of negative x? Okay, so our limit is 0, but it's e to the 0, which is 1.
I know that's what I'm gonna forget. I'm gonna get through all that. I'm gonna be like, yeah, 0, and then it's gonna be like, I forgot that's where it'd be.
Yes, do not forget about that darn E. And one more example before we part ways. Are there any questions about the algebra involved in this? What is it going to take? Some practice so you understand how to get through that process.
Just go back up to the problem that's already in my list, just so I can write it down.
Are you okay, Gabe?
This Gabe ever okay in this class?
Post-traumatic football.
Well, you know how to do half the problems because you did them last year.
Sure.
Okay?
Perhaps.
I know the concept. Getting there and simplifying using natural logs. There's
There.
no mistakes there.
Oh.
Why is there an integral? Why?
Just write it down. Stop it. Just stop it. Write it down.
Fundamental theorem of
Oh.
calculus.
Oh, I see, because it's gonna be 0.
Oh, for a hot second.
But I bet this is something we can show all our friends and be like, guess what we did in math today?
It's the cost of
That's the
DT.
only.
Oh yeah. Literally. Are you serious?
The cost of my life.
Okay, I
Well,
don't
it's
write
0
the-
over
like,
0.
Who else that writes the limits of integration like kind of a little bit to the right of the integral? You all
Yeah.
know that
I
idea,
do.
right?
Yeah.
So you did.
Are we supposed to write them on
I write the bottom one to the left and the top
Legit?
one to the right.
Okay. So what is the integral from 1 to 1 of cosine?
0.
Over 1 squared minus 1 is 0. So we need to use the Hobbitools rule, right?
What's the catch?
What's the derivative
Okay.
of 1 to x of cosine? And what's the derivative of x squared minus 1?
2x.
So I now I have the cosine of 1 over 2.
Well done.
What do you just
Yeah.
Can the whole test just be that question?
There could be
Perhaps.
one on there. Not the whole test, but there will be one on there.
When you do this by parts,
Cosine 1, 0.
Yeah, true substitution.
That's sine.
But will it
That's
cancel
a
out?
sine boy, right?
that's what I would have done. I would have been like,
Okay. Especially for ones that look like this and this. You just need to get some practice on the algebra of it. For ones that are more like the product that's indeterminate, you need practice determining how to rewrite your form so that it's a nice fraction for L'Hopital's rule. Okay. Please do your homework. You'll obviously get more practice Wednesday with our review worksheet. Okay.